Hey, all you cool cats and kittens, Miss Wagner here. I am going to be teaching you today about quadrilaterals. I'm going to start sharing my screen with you now. All right, our I can statements for today is I can recognize and describe quadrilaterals, and I can identify parallel sides as a characteristic of quadrilaterals. So you will be able to learn about recognizing and describing quadrilaterals and parallel sides in quadrilaterals in today's lesson. So we're going to do a little warm-up exercise. I want you to look at these four images right now, and I want you to think to yourself, which one of these images, shapes, does not belong? Give you about 3 seconds. I know you might be thinking to yourself that the one that is shaded in does not belong, but I want you to pay attention to the lines that each shape has, because the one that does not belong is the pentagon. The pentagon right here has 5 sides, 1, 2, 3, 4, 5. Well, each other shape only has 4 sides. So a quadrilateral is a 2-dimensional shape that has 4 straight lines and 4 angles, whereas the last picture, in which one does not belong, the shape only had, the pentagon only had 5 sides, so that's why that shape did not belong. All right, now we're going to do another one, a same but different one. Okay, I want you to look at these 2 pictures, and I want you to decide, what do you think is the same about these images, and what do you think is different? So what I'm thinking as a mathematician, the thing that is all straight is that they all have 4 straight sides. So on the left picture over here, I'm noticing that each shape all has 4 sides and they're all straight. Okay, that means that they're quadrilaterals. Let's come back to the differences. Oh, and I'm noticing that these shapes also have 4 sides. That's the same. We'll come back to the differences. But before we come back to the differences, let's review what a parallel line is. So parallel lines are 2 lines that never meet. They are distance apart. So parallel lines like to go on and on and on forever. They are never intersecting. Remember, intersect does not mean to cross. So they will go on and on and on for infinity. That's parallel lines. You might see some parallel lines in the real world. So parallel lines like the yellow lines in the street for the cars not to cross. Parallel lines like a railroad track. I encourage you today to look in your house or maybe outside your window, or maybe if you get a chance to go explore outside, what parallel lines can you find in the real world? So let's go back to what is different. In the difference box, in the purple box right here, you'll notice that the 2 shapes have only 1 set of parallel lines, not 2. Whereas the box on the left, in the blue box, all these shapes have 2 sets of parallel lines, 1 on the top and 1 to the sides. Okay? If you notice in the purple box, they only have 1 set of parallel lines. The other set of parallel lines will eventually cross or intersect. Intersect means to cross. Now, quadrilaterals, say that with me, quadrilaterals, that's a long word. Those are the 2 sets of parallel lines in the blue box to the left. On the right side, these are called trapezoids. Trapezoids only have 1 set of parallel sides. Let's move on. I want you to look at this image diagram right here. We have the word quadrilaterals at the top. Quadrilaterals are consistence of parallelograms and trapezoids. Trapezoid is a type of quadrilateral. I want you to think to yourself, why do you think the trapezoid is all alone and not expanded to any other shapes, whereas the parallelogram branches off into rectangles, rhombuses, and then squares? What makes the trapezoid different from the parallelograms? And then we also have other quadrilaterals. Now remember, a parallelogram has two sets of parallel sides. We have the lines that will go on and on forever on the sides and on the top and the bottom. The trapezoids only have one set of parallel sides, including with the other quadrilaterals. But I want you to think to yourself, why are these other quadrilaterals placed in a group together? Is it because they don't have parallel sides? I don't know. So, today we learned about quadrilaterals and what makes them the same and what makes them different. We learned that by looking at how many parallel sides can help us classify shapes as parallelograms or trapezoids or other quadrilaterals. I want you to think about one question you still have about quadrilaterals, or what are you still wondering about quadrilaterals? Today, I want you to try to find examples of quadrilaterals in your house today, parallelograms or trapezoids. Mathematicians, I'd like to thank you for joining with me today. Please go on to the slideshow to do fact or fib about parallelograms, a little review. And then I would like you to click on the Desmos, and I'll show you in our slideshow. Hold on just a second. Once you get to the slideshow on this slide, you're going to type in student.desmos.com. You're going to open up a brand new link, and then you're going to type in this code, S89RKQ. You can also click on the link right here. Mathematicians, your screen will look like this. 4 congruent side angles. This is number 2. Form a quadrilateral with 4 congruent sides and 4 right angles. You're going to click and drag the shape to make 4 congruent sides and 4 right angles. Remember, a right angle is something that is 90 degrees. So make sure when you're dragging your shape, you're making a 90-degree angle. All right, so you have 11 questions. You have 11 questions to do in the Desmos. Fourth graders, thank you so much for joining with me and learning about quadrilaterals in our lives. Bye, guys.